Okay, so this is the disc method, and hopefully you've watched the first video, and I hope the video was helped some with the visualization of it. If not, tomorrow when we are in class, I'll show you another animation for that. But in the first video, it talked about this is the formula to find the volume, and again, the radius represents the distance from the function to the axis of rotation. I actually probably should have done this on the side, but the radius is the distance from the axis of rotation to the function. So it's the function itself. We're going to square that, and then dx represents the individual slices. Once again, I should have done this on the side, but it sort of represents the individual slices that we're going to take, and we're summing all of those together. So the important thing to remember from the previous video, if we're revolving around a vertical axis, the x-axis, a horizontal axis, then we're going to use f of x. If we're revolving around a vertical axis, we use x of y. If you revolve around a different axis other than the x or the y axis, it's going to be f of x minus the axis, and so we're going to have to square that. And of course, I'll show you an example. So this first situation, we're taking the square root of x, and we're rotating it about the x-axis. Now, one of the things I want you to notice in this is that the area that's being rotated is flush. It's adjacent to, there's no spaces between the area that's being rotated and the axis of rotation. If that's the case, then that's when we use the disc method. When there's no white space, there's no space between the area that's being rotated and the axis of rotation. So we're going to use the disc method. So in this case, and again, we have to be careful to remember our dessert here. So remember pi, that's one of the normal mistakes that's made here. In this case, the distance from any point on the x-axis to the function is simply the function. So this is the distance, the radius, is the difference between the axis and the function. So our graph will, our integral will just be integral from, we're going from 0 to 4, square root of x squared. So this is just pi, the integral of 0 to 4, x dx. So of course that's x squared over 2. We're evaluating from 0 to 4. So that gives us the volume. Placing 4 in, we get 16 over 2, 8 pi. And then if I plug in 0, of course I get 0 here, so the answer is just 8 pi. Easy peasy, right? You just have to remember this formula and how to use it. For this one, we're doing this x squared plus 1. I sketched it, and we're going from -1 to 1. This is similar to the problem that we did yesterday, where it doesn't actually intersect, but because it says that it's between x equals -1 and 1, we can use this as our boundary. So we're rotating it. All of this area is flush with the axis of rotation, so it's simply going to be the integral pi times the integral from -1 to 1 of x squared plus 1 squared dx. Now, even though I didn't draw it correctly, this would be symmetrical. If I had drawn this correctly, you could see that that's going to be a symmetrical area because it's x squared. So if I want to use symmetry, I can say it's 2 pi from 0 to 1 of x squared plus 1 squared. And I use the 2 because I have to double it if I go from 0 to 1. And of course, that makes my life easier. And once again, you can do this on the calculator, but multiplying this out gives me x to the 4th plus 2x squared plus 1. And I'm integrating this, so x to the 5th over 5 plus x to the 3rd, 2/3 plus 1. Integrated from 0 to 1. So that's going to give me 2 pi times 1/5 plus 2/3 plus 1 plus, I did that wrong, didn't I? That should be x. Still gives me 1, but that should be an x. And, of course, when I put 0 in, I get 0, so this is my answer. Okay? Now, what happens when we revolve around a vertical axis? This axis is, we're revolving around the y-axis, a vertical axis. When we're revolving around a vertical axis, all of my numbers have to be in terms of y. Everything has to be in terms of y. So it's bounded by y equals 1 and y equals 8. So those will be my limits of integration. This is y equals to x cubed. But if I'm going to integrate this about a vertical axis, this has to be in terms of y. So to change this in terms of y, I take the cube root of y is equal to x. So this would be the cube root of y squared. If it's a vertical axis, we have to do it in terms of y. So we have dy. I can't use symmetry, so pi 1 to 8, and this becomes y to the 2/3. So the integral of y to the 2/3 is 5/3 times 3/5 pi, and I integrate from 1 to 8. We have to use a little bit of algebra here. So if I'm going to do this without a calculator, this gives me 3/5 pi. And then that's going to be 8 to the 5/3 minus 1 to the 5/3. Which gives me 8 to the 5/3 is 8 cubed, which is 2. 2 to the 5th is 32. So this is 3/5 pi times 32 minus 1. So this is 3/5 pi times 31. Whatever that is. What is that? 93/5 pi? Okay? And you can use your calculator for a lot of this. So once again, this is going to be about the y-axis. So if it's by the y-axis, I have to put everything in terms of y. So this would be x is equal to y squared. And this, it was told that y equals 2. This is actually like the one we did on the video, so I'm not going to finish it. But we would go from 0, these are y values, and it would be y squared, squared, and pi. We did this one on the video, so I won't do it again. Okay, so watch the next video, and then we're going to do when it's rotated about a different axis. You have one more video to watch.